Alright, so let's review how to solve quadratics. Remember, the first type of problem that you might get is a quadratic where you only have the values a and b. Right? Remember, a is the number in front of the x squared, and b is the number in front of x. Okay? So if you only have a and b, what you want to do is you want to make the problem equal 0, take out the GCF because there will always be one. Right? So in this case here, the GCF would be x, and then we end up with 2x minus 3 is equal to 0. And then you want to take each factor, set it equal to 0. So we have x is equal to 0, 2x minus 3 is equal to 0, right? And then, well, there's nothing to do here. Here's one of our answers. X equals 0 is one answer. And the other one, we just solve for x. So get x by itself. We add 3 to both sides, and then divide by 2. So x is going to equal 3 over 2. Okay? So whenever you're solving a quadratic and you recognize that this problem only has a and b, this is what you do to solve the quadratic. Okay? Now some problems do not have a b value. You only have a and c. Right? For example, let's say we have 3x squared, all right, minus 10 is equal to 0. So the first thing you should recognize is this problem only has a and c. We don't have a b value. So when you only have a and c, you want to solve this by using the square root method, right? So using the square root method, we need to get the x squared by itself so that then we can square root. So we're going to get the x squared by itself. We're going to add 10 first. 3x squared is equal to 10. Divide both sides by 3. X squared is going to equal 10 over 3. And then we square root both sides. So when you do that, the square root and the exponent, they cancel each other out. So we end up with x is equal to. Now remember, you need to have a plus minus every time you square root both sides of an equal sign. So we have a plus minus, and I would recommend splitting this up. This is square root 10 divided by square root 3. And you want to try and simplify this. So you cannot simplify square root 10, so you're kind of done there. And remember, we cannot have a radical in the denominator. So we're going to rationalize here. Multiply top and bottom by radical 3. So our final answer would be plus or minus square root 30 over 3. Right? And you can't simplify square root 30, so your answer just stays like this. Okay? Alright. The next situation you might have is when you have to solve a quadratic with a, b, and c. Right? These are probably the most common situations where you have all a, b, and c values. Okay? Now remember, the a is the value in front of x squared, the b is the value in front of the x, and the c is the constant. Right? It's the number without the x. So when you're solving problems with a, b, and c, the first thing you want to do is you want to set the problem equal to 0. Right? So 2x squared minus x, I'm a minus 3 on both sides. So I get the problem to equal 0. The next step, you want to make sure that a is positive, right? And also you want to see if there's a GCF that you can take out. So this problem here, a is already positive, and I don't see a GCF that I can pull out. Okay? So a is positive, no GCF, I move on to the next step. The next step, remember the way I taught you guys, we use the x method. Right? So this is a times c and this is b. So if I do a times c here, I get negative 6. B is negative 1. So what two numbers multiply to give me this, and they add up to give me this? Right? So see if you can find some numbers. I'm seeing negative 3, 2. If I multiply, I get this. If I add them, I get this. Once you find these numbers, remember to divide them by a. If you can reduce these fractions, reduce them. So your factors, so this, the denominator goes in front of x, so you're going to end up with 2x minus 3. And you have a 1 here, so that's going to be x plus 1. And if you want to check if these are right, you just multiply this to make sure it gives you this. Okay. Now take these factors, set them equal to 0, and just solve for x. So when will this equal 0? We add 3, divide by 2. X is 3 over 2. When will this equal 0? We minus 1. X equals negative 1. Okay? let's take a look at this problem over here. So first, I notice it's got A, B, and C, so I want to set the problem, I want to make the problem equal 0, okay? Let's say I decided to move this minus 2 over here. So then it would become negative 10x squared minus 8x, and then plus 2 is equal to 0. Now I see a GCF, and I also notice A is negative. We want A to be positive, okay? So I'm going to take out a GCF. I see 2, it's my GCF, but I'm going to take out a negative 2 because then that's going to make the A positive. So I pull out a negative 2 for my GCF, so I'm going to end up with 5x squared plus 4x, and then minus 1 is equal to 0. Okay? And then now, so I've got the GCF out here. I kind of ignored that right now. So I'm focusing on this right here. So I'm going to try and factor this using the x. So this is my A, my B, and my C now. So A times C, negative 5. I'm trying to get positive 4. So it looks like I can use 5, negative 1. If I multiply, I get negative 5. If I add, I get positive 4. And then I have to divide by whatever A is, which is 5. This fraction reduces to 1 over 1. So my factors will be x plus 1 and 5x minus 1 is equal to 0. Now your GCF out here, if your GCF does have an x, you can just ignore it, right? Because if you think about it, we're trying to solve for x. We're trying to find out what x equals. The GCF does not have an x, so it's irrelevant. It doesn't matter, okay? So we're just going to focus on these two factors. When will these equal 0? We have x plus 1 is equal to 0. 5x minus 1 is equal to 0. So x will equal negative 1. Over here, you add 1 and then divide by 5, you get 1 over 5. Right. Let's take a look at this problem right here. All right. So it's another problem where I have A, B, and C. So I'm going to set the problem equal to 0 first. So I have 3x squared and minus 5x on both sides. So first of all, make sure you write it in the correct order. It should always go from x squared, and then you have the x, and then the number without the x. Is there a GCF? I don't see a GCF. A is positive, right? So I could go ahead and start using the x. Remember, you don't want to start doing the x until you check for a GCF and make sure A is positive, okay? So A times C and B. So A times C, we get negative 12. B is negative 5. So you want to look for some numbers that multiply to give you negative 12, but that'll add or give you negative 5. So you think of all the ways to get 12 is 1 times 12, 2 times 6, 3 times 4, right? And any other ways to get 12? I think that's it. So are any of these combinations going to be able to give us, all right, a 5? It doesn't look like we're going to be able to find two numbers that will multiply that's going to give us, right, that'll multiply to give us negative 12, and if you add them, it'll give you negative 5. So when that happens and you cannot find two numbers, it's impossible to find two numbers. Remember, we solved this using the quadratic formula. So the quadratic formula, you just take the A, B, and C, plug it in the quadratic formula. X equals negative, right, and then my B is negative 5, plus or minus. B squared, so negative 5 squared. All right, it's really important to make sure you put this parentheses, especially when you're using a calculator. Minus 4 times A, which is 3, C, which is negative 4, all divided by 2 times A, which is 3. All right, and then we just start calculating this. All right, so then we have positive 5 plus minus square root. This will give us 25. When you multiply all this right here, so that'll give you, looks like a positive 48, right? Divided by 6, so 5 plus or minus. If you add this right here, we're going to end up with, let me see, 48 plus 25, 48, 58, 68. We end up with 73. Square root 73 over 6. Alright, can't really simplify square root 73. There's nothing else we can do here. Square root 73. So this would be your final answer right here, right? There's nothing else to do.